algebra students. Today's video is over using the quadratic formula. The quadratic formula is this formula that you see on the screen right now. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now that formula might look like it's really long and horrible and scary, but really, if we look at it, this first part right here, this negative b divided by 2a, that part should look familiar to you already. That is just the formula that we used when we were finding axis of symmetry. So we know how to use negative b divided by 2a. Now we have this other little part of the formula, b squared minus 4ac. This has a special name, and it is called the discriminant. We will get to the discriminant here in a couple slides. We'll learn what that is, but go ahead and label those. Now, the quadratic formula is this formula that we use to help us solve quadratics for x. That's what we've been doing the last week or so, is we've been using different methods. We've used solving by square roots. We've used factoring. We've used graphing would be the other one. We've used those methods so far to solve a quadratic equation. This is just one more method that you can add to your collection of methods in order to solve a quadratic. So in this formula, we have a's, b's, and c's. Those are the exact numbers that are in the equation of a quadratic in standard form, ax squared plus bx plus c. So if I look at the three examples on the left-hand side of the screen here, the a is going to be the number in front of the x squared. So a is 1 in this problem, b is negative 4, and c is 3. Okay, if I look at the next one, the a is going to be my 5, my b is going to be positive 3, and my c is negative 2. Okay, so you have to make sure before you start solving a problem using the quadratic formula, just as we do all the other methods, we need to make sure that our problem is written in standard form and that it equals 0. Now I have one other note here at the bottom of the screen, and that says to remember to put parentheses around the b squared term in your calculator. So when you are entering b right there, it is very, very important that you put parentheses around the b in your calculator. So if I was doing this first problem right here, my b is negative 4. Negative 4 squared, the negative 4 in parentheses is going to give us 16, whereas if we don't put it in parentheses, it would give us negative 16. We want to make sure that we put parentheses around our b squared. So let's look at an example and see how we use this formula. Our first example, what I always like to do first is, number one, make sure it's in standard form. After that, I go ahead and off to the side, I identify what my a, b, and c are. So my a in this problem is 6, my b is 5, and my c is negative 4. Now write down the formula. You're going to want to write it down multiple times. When you start this, each problem you do, it's best to rewrite the problem or rewrite the formula right there for you. That way, it's always there, and you'll start to memorize it that way, and that's what we want to get to. So I'm going to take my formula. It's already written down for me, so I just start plugging in. I need negative b. That means the opposite of b. My b is positive 5, so I write down negative 5. Then I have plus or minus the square root of b squared. I'm going to go ahead and write my b, which is 5, in parentheses, being squared, minus 4 times my a, which is 6, times my c, which is negative 4, and I divide all of that by 2 times my a, which is 6. So all we're doing is plugging into that formula. Now, next step, do not try and do this all in your calculator in one step. Also, don't try and do this without writing every number in the formula where it goes. I need to see your work, and that way you won't make mistakes as well. So the first part I always do in my calculator. Now, you can't see me doing this in my calculator, but I always do the discriminant first. Remember, the discriminant is the stuff inside the square root symbol. So I'm going to go ahead and copy down the negative 5 plus or minus. Now I'm going to figure out what that inside part gives me. So I'm typing in my calculator right now, 5 squared minus 4 times 6 times negative 4. When I do that, I get 121. 2 times 6 is 12. So all I've done is simplify my discriminant and simplify the 2 times 6 to get 12. Now, I noticed that I have this plus or minus sign here. That plus or minus sign is what's going to enable me to get a possible 2 solutions. So I'm going to check the first one, which would be to do x equals -5, and for my first 0, I'm going to use the plus sign. So I'm going to have -5 plus the square root of 121. Well, 121 is a perfect square, so the square root of 121 is 11, and that's going to be divided by 12. Then I'm going to have my other solution to this problem, my other 0, which is x equals -5. Instead of the plus sign, which I just used, I'm going to use the minus sign. Minus the square root of 121, which is 11, and I'm going to divide that by 12. So in each problem, you have to do the plus and the minus. That's what's going to get you your two different solutions, okay? Now I'm going to figure out what this is. So first I want to do what is -5 plus 11. Well, we know that that gives us 6, and so I have 6/12, which reduced equals 1/2. I look at my other solution, and -5 minus 11, that's -16/12. I need to reduce that answer. That each 16 and 12 have a factor of 4, so this reduces to -4/3. So those are the two zeros to my original quadratic that I started with. Okay? Those are the exact same answers you would get if you solved this by graphing or factoring, the other methods that we use. This is just one more. Okay, let's do another example here. Okay, I notice in this problem I don't have this in standard form yet, so I'm going to go ahead and get this equation in standard form set equal to 0. Okay, now that it's in standard form, I'm going to identify my A, B, and C. My A is 3, my B is 1, and my C is -5. My formula is written down. You guys write it down. Now I'm going to start plugging in. I have x equals the opposite of b. Well, my b is a positive 1, so I will write -1. If your b is negative, here in the formula you would enter positive, just as we did with axis of symmetry. -1 plus or minus the square root of my b is 1, so 1 squared minus 4 times my a times my c. Divide all of that by 2 times my a, which is 3. Now remember, the first thing after I get everything plugged in is I figure out what my discriminant is. So I'm going to see what all of that stuff inside my square root sign equals. So I have 1 squared minus 4 times 3 times -5. When I work that out, I get 61. Divided by 2 times 3, which is 6. Now 61 is not a perfect square, so this one's going to be a little bit different than the last one. My two solutions are going to be x equals -1 plus the square root of 61 divided by 6, and my other solution, x equals -1 minus the square root of 61 divided by 6. Okay, now I need to figure out what this is. So once I get it down this far, I then type into my calculator in one step, so I don't round a whole lot. -1 plus the square root of 61. Take that answer, do not round it yet, divide by 6. Now I can round and say x equals 1.135. Okay, the next one, I'm going to type in -1 minus, this time, the square root of 61. Take that, do not round it yet in your calculator, divide by 6, and you get x equals -1.469, we'll call that. Or 0.468, I guess, would be a little bit more accurate. Okay, so those are the two solutions to this particular quadratic. Those are the zeros. Now, here we are to this thing called the discriminant that I keep referring to. The discriminant is the part underneath the square root that tells you how many solutions you are going to have. Many of you have asked me in the last week or so, Ms. Sokolowski, is there any way we can tell, just by looking at an equation, how many zeros it's going to have? And I told you, you don't know that yet. Well, now you know. By solving the discriminant, I have a way of determining how many zeros my graph is going to have, my function. So, when we solve out the discriminant, if the discriminant is positive, if we end up with a positive number as our discriminant, that's the b squared minus 4ac part, then I am going to have two real solutions, 2 zeros. That graph will cross the x-axis 2 times. If we work out the discriminant and we get the discriminant equals 0, I'm only going to have one real solution. Finally, if the discriminant is negative, can we take the square root of a negative number? Absolutely not. That means that there are no solutions, no roots, no zeros to that particular function because the discriminant is negative. We can't take the square root of a negative, so there are no solutions. So let's just determine in these three examples whether they're going to be one solution, two solutions, or zero solutions. So to do that, I use my discriminant, b squared minus 4ac. So here I have b squared, which is negative 2 squared minus 4 times a times my c, which is 2. So I'm going to work that out. I'm going to do negative 2, and I'm going to square that. We know that's 4, minus 4 times 3 times 2. That gives me an answer of negative 20. Well, that's a negative answer. It's less than 0. So therefore, I have no solutions here. There would be no zeros. Okay? If we look at the next example, I have b squared, so 11 squared minus 4 times a times c. When I work this one out, I get 121 minus 4 times 2 times 12, and that gives me an answer of positive 25. When I get a positive answer, something that's greater than 0, I'm going to have two solutions to this problem. Lastly, when I do this one, I have b squared, so 8 squared minus 4 times my a, which is 1, times my c, which is 16. 8 squared is 64 minus 4 times 1 times 16. That gives me an answer of 0. When I get 0, I'm going to have one solution. Okay, so using the discriminant, you can tell how many solutions you are going to have to any given quadratic. All right, that's it. See you guys.